Okay, we're going to now start on animating characters. The character controller we talked about last time was for simple cubes and so forth. But of course, we're more interested in moving around humanoid characters, things that we want to have walk, jump, run, shoot, do all kinds of different stuff. And for this, we use something called the Mecanim system. Let me get my slides going here. So Mecanim animation is based on animation clips. We made some ourselves, but character content often comes with animations that were built in Blender or some other program. These clips usually are comprised of a simple piece of motion, such as running, walking, jumping, whatever. And they're usually part of the imported FBX data from our character that we get. And one of these animation clips looks something like this. We've got the start frame, that's right there, and the end frame, that's right there, because often these animation clips have more than one part to them, or they'll repeat the motion over and over again, and you have to trim it down. And as you do this, a couple of spotlights here show you how well it's looped. If you're a walking animation, you want it to loop properly so that the walks don't have hiccups in them, and other things that are indicated by these red lines. It has a lot of properties here, looping, how it's based. I'll let you read about that in detail in the documentation. The other thing that we need for our Mecanim animation is an Animator component, not an animation component, but an Animator component. And this has a couple of things that we need to look at. One is the controller and the other is the avatar. Interestingly, the real meaning of the word avatar is a manifestation of a deity or released soul in bodily form on earth, an incarnate divine teacher. And it comes from the Sanskrit word avatara, or descendant. I just love that. Back to Unity. The Animator controller is what we're going to use to set up the behavior of our character. The Animator controller is a state machine. It's going to have different states and blend trees and transitions and potentially events and other things that we'll talk about as we go along here. You can create an Animator controller window. You can create one, and it'll look like this in the project view. It has a little icon for a state diagram. And once you've made this controller that has the different states and transitions, you can drop it into the Animator component of any character with an avatar. And we're going to see this as the ability to set up animations for one character and then use it on many humanoid avatars. So a controller looks like this. It's a state diagram. It's got various states, the little squares, and it has transitions, the little arrow lines between them. It has parameters that we can set from scripting and use that to control our transitions. We also have layers that I'll talk about later. These parameters are variables that are defined within the animation system, but mainly we manipulate them from scripts. A parameter could be updated with a curve, then accessed from a script that picks a value off that curve, and so we could control the pitch of the sound effect or whatever. When we see blend trees, we can also have a parameter that controls the blend tree. Parameters come in a number of different flavors. You can have an integer, a whole number, a float, a number with a fractional part, Booleans that are true or false, and triggers, which I won't really talk about. You can read about them yourself. Parameters are assigned in a script using functions like set float, set int, set bool. These are kind of obvious. A simple example here, I'm going to set up a character that runs forward. So in my script, I have a private animator of type animator, which I get a cached copy of in the start function using getComponent. And in update, I'm going to get the horizontal and vertical axes, and I'm going to set its speed as h squared plus v squared. So let's look at that. This is here's the controller for this. Where's my character? Here's my character. Has an animator. It has a controller. 0, 1, run. 0, 1, run. Has these states and transitions. I'll talk about all of these in a minute. Important here is this speed. That's the thing that I'm setting in the script. And the speed is going to be used to control the transition from idle to run. So let me just play this so that we can see it in action. Here's my little character. Run is triggered with the up arrow. So I start running. And you notice we can watch what's happening over here in the controller. Right now it's idling, so the idle animation is playing. As I run, it transitions to the run, which is a looped animation. So it's triggering over and over and over again. And I don't want to run off the edge of the world there, so I'll stop. So that animator set float speed to h squared plus v squared, that's the thing, that's the parameter that is appearing here in my speed that is controlling this transition that I'll talk about in a second. Let's watch the speed here. Watch this speed as I run, and you'll see the speed goes up to 1 and then drops back down again. I can actually make it go 2 by pressing the horizontal axis 2, but it's not using that, so it doesn't matter. So these animation states, these building blocks of our state machine, each one contains an individual animation. And the events in the games, when we change that parameter, that triggers a transition. It transitions from one state to another. The basic idea is that a character is in some particular action all the time, and these actions depend on what the gameplay is: walking, running, idling, jumping, whatever. The character in general has restrictions on what the next state it can go to. For instance, a running jump could only be taken from a character that's already running, not when it's standing still, idling. So it should never switch straight from an idle to a running jump. Taken together, this whole set of states, the set of transitions and the variables or parameters that define the current state, form this state machine. And Often when thinking about these, we represent as some kind of graph. From idle, we can go to standing jump, and from standing jump, we can go back to idle. From idle, we can go to walk. From walk, we can go back to idle, or from walk, we can go on to run, and so forth. That kind of state diagram. And Mecanim allows us to build this directly with all the arrows and everything. This requires very little coding. It's really a tremendous tool. Each state has some motion associated with it that plays when the machine's in that state. And this enables us to design complex motions without having to do any coding at all except to set the parameters. An animation controller has these states, transitions, and possibly events. We can actually make sub-state machines by grouping a bunch of them together and calling it a single sub-state. And when we select one of the states in the controller, we see the properties for that state. We see what animation is included. We see its speed. We see what transitions from this state are. It can go from run to jump, and this has 3 transitions out of it. In my little state here, the idle has the idle function. This is one of the animations over here that I can see. It just stands there and does nothing. But the run state has a run animation. I can see the run animation here. It runs forward. It's looping. And these are all part of my little character here that I'm playing with here. So each of these states have an animation clip associated with them and transitions. The run can transition to idle. The idle can transition to run. We have a default state. This is the yellow one. This is the state that we transition to automatically from the entry state. We also have an exit state that immediately recycles us around to the entry. We have a default state that we can set as default. The solo and mute let us isolate things for previews. And we can create a state by clicking on the Animator controller window and selecting Create State Empty. This way we could then define in that empty state what motion it has and its transitions. You can also drag an animation from your project view into the Animator controller, but be warned, this only works with Mecanim animations. The any state we can also use. This is a special state that exists for a situation where you want to go to a specific state regardless of where you are, what state you're in. This is kind of a shorthand for adding outward transitions from all the states in the machine. And because it's in any state, you can't go to that state, so it can only have outward transitions. I'm not going to use any of those here. So the transitions. The transitions define what happens when you switch from one state to another. And these, only one transition can be active at any time. And the condition that controls that transition can be an exit time when the animation has completely played. Actually, you can specify how much of the animation is played with the exit time. 0.95 would mean that 95% of the clip is played. But more often we use conditional predicates. For instance, our parameter is less than or greater than or equal to various floats, or if a Boolean is checked. So here's the transition for the out of idle. We transition out of idle if the speed is greater than 0. That's our condition, speed is greater than 0, and then it's going to transition out. You can adjust the transition between the two clips by dragging this stuff around. So the idle plays along here, then it goes into its transition, whose duration you can set by moving these little sliders around. It transitions into the run, and then it's in the run animation, and you can get a preview of what this looks like here as it transitions from the run. You can actually move it back and forth and see how the transition runs. This little white line is kind of a measure of the center of your character, and so the blending can sometimes help you to line up those lines as it transitions from one state to another. This is a bunch of fiddling. You just have to fiddle to get it to look right, to make the steps match up, and other things. Animation transitions. Now, another kind of state is a blend tree. And blend trees are kind of like transitions. You're moving among different states, but unlike the transition between states, a blend tree kind of combines two different states with different weights. And so where the transitions move from one state to another, a blend tree allows multiple animations to be blended together by some weighted average. So it combines different animations together. An example might be a walk to run. Instead of transitioning abruptly from walk to run, you would use a blend tree to gradually transition from walking to running as your speed or whatever it is increases. And of course, in order for this to make sense, the animations have to be aligned properly so that the movements make sense. You want the feet to hit the ground at the same time in the different animations. The animations use something called normalized time, so usually this works out pretty well. With a blend tree, you need to create a new blend tree, just like we created an empty state. And a blend tree will then look like a little square, but when you click on it, it will expand out to show the different states that you're blending with the blend tree, as well as the parameter that you're using to control that. With the empty blend tree, when we first make it, it has no states. We have to add the different animations that we want it to blend among. And blending comes in a number of different flavors. We have 1D blending, 2D blending, and there are some other options. I'll talk about 1D blending in here. 1D blending blends the motion according to a single parameter. 2D blends with two parameters. So you could have like X and Y or forward or side motion with a 2D blending tree. Now, so we need to select a parameter that's going to control it. In this example, we'll use direction. Direction is going to be our horizontal axis that goes from -1 to the left to +1 to the right, with 0 denoting straight ahead running without leaning. And I have 3 animations. I have a run left, a run right, and a run straight forward. And this is what the blend tree looks like once you've set this up. We've added these motions, and they have various thresholds, and they have this little triangle diagram that shows the various weights that blend between these, among these different animations. Let me get into the right scene for this. This is scene turn. So our character now has a different controller, the run turn controller. Run turn controller. Oh, so here the run now is a blend tree, and I can switch back to the base layer here. This is the base layer. Clicking on the blend tree shows me my blend. I have over here the clicking on the blend tree shows the parameter that I'm using, the direction, and the run left and run right and run forward with the various thresholds here. And I can preview what this is going to look like. I don't know why his head's cut off there. And I can actually move this around, and you can see the animation change as it runs to the left and runs to the right. It's blending between those three animations as I move around. I can also see this over here. Let me run here. Whoops, I want to minimize. So if we watch our character, if I look back at the base layer, he's in the idle function. If I start to run, it moves into the run animation. The state diagram here for run, as I turn, that direction goes to the left. As I turn, that direction goes to the right. And you can actually see which state is weighted by the little changing colors there as of the different animations. So let's look at that script here. We have these little triangles. These are the value of these are the thresholds. Nominally, they're all ones. There are a bunch of settings here. We can automate the thresholds. If we have, for instance, say, a motion where the parameter went from -90 to +90, and we had 5 different motions, pressing automate will set the thresholds to be at -90, -45, 0, +45, and 90. It automatically sets up the range to be even. You can also set them yourself. The compute thresholds also triggers on various parameters: speed, velocity, x, y, and z, angular speed, either in radians or degrees. And this could be used with different animations that cover different speed. Our animations here are now going to actually control the root motion of our character. Some of the old animations don't do this, but the more modern ones do. Triggering, computing on speed is going to set it so that at a value of 3, it's going to be blended about halfway in between walking and running. More advanced stuff. Okay, so here's the script that sets the direction. We're still using speed to control our movement forward with h² + v², but now I'm setting the direction parameter with just the h, and I'm also adding this third argument, direction damp time, which is a parameter, a tuning parameter here. Direction damp time and the time delta time. This is going to blend. This is going to not just set the parameter abruptly, but it's going to go gradually to the value of the parameter over some amount of time that you control with this direction damping time. So the parameter doesn't change abruptly. It can change more smoothly as we go. So that's all there is to setting up our character to now run left and right. we run straight forward, we run to the left, we run to the right. It's blending those different animations as we go here. Quite cool and very simple. The state diagram is still this very simple idle and run. Run is now a blend tree that blends between 3 different animations, and away we go. As I mentioned, you can go directly to the value speed, or you can interpolate gradually over a specified time interval, controllable by a parameter. Animation layers let us control different parts of our character at the same time. For instance, you might have the character walking, running, jumping at the same time that you want to have an arm throw something. And we can do this by adding layers to our system. Let me get to the next one. I think I'm going to go to wave here. So with wave, we now have layers. Here's the layers over here. We have a base layer and an arm layer. And these are 2 different state diagrams. This is going to control the whole body. The arm layer is going to control, here's a trick, pressing the A key focuses your state diagram so that it all fits in a window. This is our arm that's going to transition to a wave. I'm going to wave my hand. Here it gets a little more complicated. Also, we have to have a mask that specifies which part of the body is used. The mask is something we build. Where's a mask? Here's a body mask for the right arm that looks like, where's the mask? Here's the mask. So we're picking the arm that we want to have this mask control. And this is something that you create just like any other object. So when we have this mask, we can now add in our animator. We can, first of all, check to see that we have 2 layers. If the animator layer count is greater than or equal to 2, then we can set a weight for those animators. And in our update function, we can now have a wave button. If we press the fire 2 button and the animator's layer count is greater than 2, then we can set a Boolean high by toggling the get Boolean. We can also get parameters back from our animator, just like we can set parameters, we can get parameters. So here I'm just toggling the Boolean animator high with this bool. The rest is exactly the same. And so now when I press, I believe it's the control here, press the fire 2 button, he now waves. And that state is true, so he's going to continue to go through the wave function, which has a default transition in and out as it plays the whole animation. And of course, as we're running, we can still wave and turning and wave, and he continues to wave as we run. These animations are on separate layers and are controlled that way. Okay, so I want to add a jump condition. The jump condition will add another state that has a jump animation. We can only enter the jump if we're already in the run, so it transitions out of the run, not out of the idle. And in my script, all I have to do is add uh, a, a Boolean if we're in the run. Then when the jump button is pressed, then we set the jump Boolean to be true. Otherwise, we set it to be false. So now we're in the run, turn, jump scene. Our character now has the run, jump controller. The run, jump controller, I have to get in the correct layer here. So now I have a jump. It triggers on the bool jump parameter, and let's play this. The space bar is the jump trigger. So here we are in the idle animation. Pressing jump doesn't do anything because we're in the idle, but as I'm running, if I press the jump, you watch the jump Boolean turns to true, and my little character does this nice little jump. The transition here is all tuned up. Here in the transition, I've kind of matched things together. It takes some fiddling to get these animations to transition without step hiccups. It's a lot of fiddling to get things right, but of course, once you do, it looks great. So that's a jump. That's pretty easy. So I wanted more. I wanted to add a slide animation. With this one, I'm going to do something even fancier. I'm going to add a behavior. A behavior is a state machine behavior rather than the mono behavior. There's a template. When you create a behavior, it fills out a template for you. It has a number of on-state events, two of which are on-state enter and on-state exit. With this slide animation, I'm going to instantiate a particle effect, some sparks that when he slides. So on state enter, when this state enters, it's going to instantiate the particle effect. It's going to put it at the animator's root position with an upright rotation. And then I think I'm going to rotate it so that it sprays the sparks out in a particular direction. And on state exit, I'm going to destroy that clone that I created. So let me show you this, and then I'll show you how to set up the animation. Here my character now has a slide animation. The slide animation, sprint slide to the right. I'll show you where I got that in just a second. The transition out of it triggers on, the slide Boolean, just like we triggered on the jump Boolean. So when it's true, it triggers. And the exit here, it doesn't have a conditional exit. It has an exit time. So it plays the entire slide animation before returning to the run animation. So it goes back to the run animation, but not on a conditional case. It now is going to play out the entire animation and then transition back to it. And you can see how that works and do the fiddling to get things to match here as it goes. A lot of fiddling. So the slide is pretty simple. If the fire button is pressed, we set slide to true. We set, if it's not pressed, we set slide to false. So again, scripting is pretty simple here. We don't have much that we have to do with this. And now, as my character runs around, I should be I should be in the idle state. I'm in the idle state. I start to run. Run is the blend tree. I can jump. It goes into the jump animation. That's also one that uses an exit time. And now a slide, I believe, is the left control. And there he slides, and the particle effect manifests. Oops, don't run off the edge of the world. Pretty cool. Pretty cool. The slide, I've added this behavior. And finally, last thing I want to add here is I didn't like the way the character stopped so abruptly. So again, I'll show you the raw mocaps in a second. But I found a stopping animation. And so nothing changes in the scripts here, but now instead of transitioning from run to idle directly, I'm going to transition through this run, fast, stop, idle animation. So it has a transition, and then it plays out the entire animation with an exit time, and then it goes back to idle. So now it stop looks like this. Here's the controller. Here's the run stop controller that now has a slide. So it's going to transition out of this when the speed is less than 0.1. It's going to transition back to idle when the exit time is done. And it takes some fiddling to get this to look good, but the fiddling is all happily done. So here we are with our new run stop animation. So instead of stopping abruptly, it's now gonna, let me get on some white here. It's now gonna stop kind of gradually, and then it's back in idle again. This stop is, I think, better than the sort of abrupt transition from run to idle. So let me show you the mocaps here. Oh, one more little trick, a boost feature. The animation speed, the animator has a kind of global function, the speed, that controls how fast all the animations run. So in my script, I'm just gonna, when I press the Q key, I'll boost the animation speed 4 times. When I press the E key, I'll reduce it. So I'm gonna have a high speed and a slow speed. And I do this by setting the animator's speed now to this boosted value. And now my little character, and I didn't change anything else in either the controller or the script. And now when I play this, I can boost and run real fast, and I can E key and it goes real slow. And this is handy for actually looking at how the different blends go. Here's my jump, run in slow motion. Here's my slide in slow motion, and fiddling to get the steps to work right. So that's our run through with the Mecanim animation. Oh, one other thing, the creation of the avatar that I mentioned way back, the animator has to have an avatar. With humanoid animations of the kind that we're working with, they're pretty easy to generate. In your FBX, the import for the dude, you've got this rig button. So somewhere here is my little character. uh, um, the dude, where is the character? Here's the dude who looks like this. And with the rig button, I select humanoid and I press configure. And if a check mark shows up, everything is good to go um, without doing anything. This adds to my the dude avatar that I can then drop in the Animator. If for some reason it's unable to do it automatically, you'll see an X here, and you then have to configure it manually. You have to go in and select the various parts of the body and which goes with which if the automatic can't figure it out. You can save this as a template file. If you have a whole bunch of characters that all use the same broken skeleton that doesn't work automatically, you can do it on one of them and save that as a template file and get it going. There also are generic and legacy settings here. Most of the modern ones, at least humanoid, work appropriately. Generic and legacy are for old-fashioned animations that don't have root motion, and generic is for things that aren't in any way related to anything that we would consider humanoid. I might give you some notes on this, but I'm not going to go through it here in class. So finally, let me show you something I got someplace, raw mocap animations. It's a huge set of raw motion capture animations. Here's just a little scene with a bunch of characters that are running around. I'm not controlling them, they're just kind of cycling through a bunch of different animations. You can see how easy it is to apply this to different characters. There's that sort of low poly default, there's the dude, and there's this fat teddy bear that I've got from someplace. The animations, there are tons of them. They're like a whole bunch of different idle animations. There are various interacting animations. We can kind of look at them here in the when we click on one of these things, we look at the animation, we get a little preview of what it does. The character is crouching down, and this is an example of one that is, and this is what they mean by raw. It hasn't been spliced out to select the appropriate part. This animation goes through several different takes of this guy doing different things on the ground here with his little character. And we would pick out the cycle that we want by picking a start and an end of the animation that we wanted. But that's a whole fiddle factor that you can go through. But this is where I got the sliding animation and the run to idle stop animation. I found these in here, exported them, put them back in the game. That was huge. So I'm done with that. Back to the main screen. And I know this was a long lecture with a lot of stuff, and but have a look at the game folder that provided. I'm not sure if I'll be able to upload the raw mocaps, but I'll give it a try. I'm at home where the internet's kind of slow. So I'm going to stop recording here, and I'll see you in class, and we can talk about things there. Please try and watch these before class. I should have said that at the beginning, huh? But I'll stop recording here. See you in class. Bye.